The broadcast is now starting. All attendees are in listen-only mode.
Everybody, welcome back to Amazing Mechatronics and Young Engineers of Today, but mostly Amazing Mechatronics. So what we're going to do today is we're going to continue with Scratch. However, we're going to launch directly into our first project, which is going to be a small Pong game. The small Pong game is going to have, obviously it's going to have a ball and a paddle. It's going to have a win and lose condition. It's going to have a few different things. Hopefully it will be a good introduction to all of the sort of basic tenets of programming so that you guys can get pretty comfortable with them and confident to experiment with them on your own terms. Because that really is the foundation of programming, is the having enough knowledge to be dangerous. So that's what we're going to do, is we're going to get started on Pong today and hopefully make some decent progress on it. In my last class, we got as far as adding a lose condition as we sort of walked through everything. Sometimes it might be a little slow for the liking, but I try and explain everything that goes on in the background so that you guys have a good understanding of why we're doing these things, not just how we're doing these things or what to do next. Because if you understand why, then you guys should be able to answer what we're going to do next based on what we're trying to do. Not that I'm going to quiz you. But yes, so without any further ado, why don't you go ahead and get Scratch open. Just go ahead and go to scratch.mit.edu and then click on Create, because we're going to create a whole new project from scratch. No pun intended. Once you've got this screen and you're on a new untitled project, just go ahead and raise your hand. Just waiting on a couple more hands and then we'll get started. Give it about another 30-ish seconds to a minute. Alrighty. So, we're sitting here on the Scratch screen for Scratch. It's pretty familiar at this point, I'm sure, to you guys. I think you know at least a little bit about what's going on here because you guys have dealt with Scratch at least a couple of times in your life so far. But let's just start from the beginning. So the first thing we're going to do is we're going to delete the Cat Sprite. Just right-click on the Cat Sprite, select Delete, which is a little strange, but there's a reason for that, which we'll get into in a minute. Part of it has to do with the fact that we don't actually need the cat in the game, unfortunately, as much as I do enjoy the cat. So, we'll just have to deal with that. But yeah, so go ahead and delete the cat sprite. So we're just left with a blank backdrop. Just a white backdrop, nothing going on in the background. This is going to be about as blank as it gets for our program. Then we're going to add a couple of sprites to it. We can do that by clicking the little troll doll looking thing. I guess it's supposed to be a sprite, but it's weird. Yeah, super weird. So if you mouse over it, it says choose sprite from library. Just go ahead and click, and bam, you got a whole sort of wonderful collection of clip art right there at your fingertips. There are a number of different people and poses. There's an airplane and a dude who thinks he's an airplane, and there's some Cheetos in a bowl and a crab and a single symbol, and a cowbell, and an X, and you get the idea. Also a bow tie. What we're going to do is we're going to select the beach ball and hit OK. And boom, there you go. There's your beach ball. Now we're going to need a paddle, so I'm going to go back to the same thing and go through all of my absolutely 100% wonderful selections here, and look for. The squirrel makes me laugh every time. It's just a very low-res picture of a real-life squirrel that looks incredibly distressed, and I don't know why it exists here. We're going to look for the trampoline, though. Let's not get distracted by the squirrel. Keeping in mind, I said let's, and you guys did not, and I was the only person who got distracted by the squirrel. Perfect. So now we got our trampoline, and we got our ball. Hey, we got a Pong game. We're done, right? That's all we need. Because we got a ball and we got a paddle. Look at it go. So I don't know. I've had a long day. The idea here is we're going to have a ball that bounces around. It's going to hit the top of the screen. It's going to bounce. It's going to hit the side of the screen. It's going to bounce. It's going to hit the trampoline. It's going to bounce. If it gets past the trampoline, though, if it gets down here, we're going to lose the game. It's going to be game over. Done. It's also going to keep track of how many times we bounce off the trampoline. It's going to give us a point each time we do that. And it's going to say, hey, game over. Your score was 4. Yay. Or 12 or 100 or whatever it ends up being. So the basic idea behind this game is it's just one player Pong. It's like imagine if you had a racket and a tennis ball and a wall and you just hit the tennis ball against the wall. You want to make sure that the tennis ball does not go past you. So we need to figure out how exactly we're going to build that. What's the best way to start? What's the best thing to do? Where should we put everything? Usually in instances like these, I don't know if you can hear this, the cat is very enthusiastically sharpening his claws on my chair. Okay, there we go. Usually in cases like these, we want to sort of break it down into maybe a very simple document that explains it to ourselves so that we can think through it in our head. So let's go ahead and do that. I've conveniently got a document already open. So let's see here. Ball bounces off walls and trampoline. Do not let ball get past trampoline. That is, in essence, an explanation of how the game works. But hopefully you guys remember the phrase from the last class. It's a phrase that I'm going to repeat often. It's a phrase that you're going to hear a lot, and it's a phrase that you're going to think of yourself a lot if you start programming a lot. And that phrase is computers are dumb. Writing something like this makes perfect sense to us. The ball bounces off the walls and the trampoline, and you don't want to let the ball get past the trampoline. However, we need to break it down more for the computer. We need to make it even simpler. And thankfully, we're running Scratch, which does a lot of the heavy lifting for us. Otherwise, we'd have to break it down even more for the computer than what we're going to do when we're done here. So let's see here. So we're going to say ball can bounce on walls and trampoline, but cannot bounce on bottom. Player gets points each time ball bounces off trampoline. Keep track of points. Let's see what else here. Trampoline is controlled by player. Trampoline. Nah, let's skip that one. Game stops when ball gets to bottom area past trampoline. We're getting closer. We're getting closer. However, we can probably break this down even more into what the ball can do and what the trampoline can do. So ball moves forward each always. Ball bounces on walls and ceiling. Ball bounces on trampoline. Ball does not bounce on bottom. Game ends if ball hits bottom. Ball bouncing on trampoline gives player points. Trampoline moves left and right. Trampoline is controlled by mouse. Now we're getting somewhere. Notice these are semicolons. Maybe I've been coding too much. But this is starting to get to a point where it's broken down enough for a computer to understand. And it gives us an idea of where we might want to start. Notice how there are 1, 2, 3, 4, 5, 6 things that describe what the ball should do, but only 2 things that the trampoline should do. I accidentally clicked away from it. Only 2 things that the trampoline should do. So this gives us a better idea of maybe where to start. Maybe we should start with the easier thing, the trampoline. Because if it's got fewer instructions, it probably means it's going to require less code to make. All right, so let's test it out. Now what I'm going to do is I'm going to click on the trampoline before I start coding anything. And by coding anything, I mean dragging and dropping. But it's coding. And you might be saying, why do you do that? Well, you might not be because you're already familiar with Scratch, but you might be saying that. Well, the case is because whatever code you put into Scratch, this is just as an example, do not copy what I'm doing here. Whatever code you put into Scratch is going to be tied to whatever sprites you have currently selected. So notice how I've got the trampoline selected and I got all this code in here. If I click on the beach ball, it disappears. My code has not disappeared. The code that dictates what happens to the trampoline still exists. It's just I can add separate code that controls what happens to the ball in this screen. And let's put in a light blue one and this one so that you can see visually if I click on the trampoline, then our other code is back. And if I click on the ball, then our code here is back. So this allows us to make our code more complex because we can have, at the same time easier, because we can have code that controls just the trampoline, we can have code that controls just the ball, we can have code for just the backdrop. If we add any new sprites, we can have code that controls just those sprites. We've got all kinds of options as far as setting up our control is concerned. For now though, let's focus on the trampoline. So I'm going to go back over to motion. Now what I want to do is I want to make sure that the trampoline is controlled by the mouse. I want the trampoline to be in whatever sort of horizontal position that the mouse is in. So if we look through all of these, we got a couple of promising ones. We got point towards mouse pointer. We've got go to X and Y. We've got change X by and set X by and change Y by and set Y by. Let's break this down a little bit. If we just want the trampoline to move horizontally, remember our X and Y values down here in the lower right-hand corner of the canvas? If we just want our horizontal on the trampoline to change, one of these 2 is not going to change because one of them represents horizontal and one of them represents vertical. Which one is not going to change if we're just changing the horizontal? If you got an idea, you can throw it into the question box. Correct. Yep. That's the ticket. The y-axis will not change. That's pretty, I mean, you guys are taking like pre-algebra and, algebra, and it's got like geometry sort of beginnings and graphs and stuff like that. So you know about X and Y. So you know that X is the horizontal and Y is the vertical. So when I say only the horizontal part of the trampoline will change, you guys know that that means the X. So perfect. That ties nicely into, again, computers being dumb, in the sense that they don't assume anything. So if we just tell it to change x, it will never, ever, 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 ever change y. That's useful. So we can use one of these two here, the change x by 10, or the set x to whatever, in this case, 0. Now here's where things get a little tricky. I keep using the term change x because I'm a bad person who should not be mixing his terminology. Out of these two, we're going to want to use the set x to whatever. The reason why we don't want to use the change x by whatever is it sounds very similar, but it's a slightly different thing. If we use the set x, what it's going to do is it's going to place the trampoline at whatever x position the mouse pointer is at. If we use the change x, it's going to change the trampoline's x position by whatever the mouse pointer is at. Wow, that didn't really clear things up at all, did it? So think of it like this. A car is going 60 miles an hour. If you press down on the gas, the car starts going faster. However, you can press down on the gas a little bit, or you can press down on the gas a lot of it. So either you can start going over the course of maybe 30 seconds from 60 to 65 miles an hour, or over the course of 30 seconds from 60 to 90 miles an hour. Don't recommend doing that. But you could. There is sort of a control over how quickly you can change the car's speed. That's what this change x is referring to. It's referring to how quickly you change x. Confusingly, if you set this one up, where you move the mouse pointer will determine how quickly you change x, as opposed to where the trampoline's x position is. I know that that's sort of a weird thing to explain at this point, although it may have made perfect sense. The best thing I can do is recommend that on your own time, you should test it out and see what happens and see why it happens. But for now, though, we're going to set the x to a value. If we go to our handy dandy sensing category, we can see all of the different things that we can set x to. We can set x to touching mouse pointer, doesn't really make any sense. We can set x to touching color, still doesn't make any sense. We can set x to ask what's your name and wait. Nope, doesn't make any sense. Notice how these don't really fit. I mean, they stick to the bottom and stuff like that, but this has a very specific shape, and some of these have the sort of the oval shape, the capsule shape. If we drag these in, these will actually fit into the text box. So we could set x to answer, we could set x to loudness, we could set x to timer, we could set x to days since 2000, which would be a wild ride. We could set x to, well, maybe mouse x. Maybe that would be a useful thing to set it to. Answer's sitting there right in front of our faces. So if I click the green flag, nothing happens. Wow, amazing. Wow. And if you guys remember back to Tuesday, that's because we got to add the event when the green flag is clicked. So I'm just going to drag it and click it to the top right there. Sorry if that was super loud. I just forgot that I had a microphone right next to my face. So let me go ahead and click the green flag again. Sure enough, trampoline moves to the position of my cursor, which was right where I clicked the flag. If I move my cursor and then click the green flag again, the trampoline moves, but it does not continue to move with my trampoline. What critical thing am I missing from this bit of code right here? Because when I click the green flag, I want the trampoline to continually, some might say for forever, change its position to the X position of the cursor. So what am I missing from this equation? Because here's the thing, it's only checking it once. It's only setting X to mouse X once. How do we make sure it will continue to set X to mouse X? Yep, that's the one. going to be that forever node right there. Just slot that in, hit the green flag, move the cursor around, and look at that. Now this trampoline is faithfully tracking the position of the mouse cursor, and only the X position. Notice how I move the mouse cursor up and down, and the trampoline isn't moving left and right very much. And the only reason it's moving left and right is because I can't move the mouse cursor up and down perfectly. If I had like robot hands or something like that, robot arms, I could potentially move it perfectly up and down, but I don't have the patience to try right now. So it's still going to move left and right a little bit. But otherwise, it is very faithfully moving along with my mouse cursor. Fantastic. Wow. So let's see what we got here. Let's check our little design document here. Trampoline moves left and right, and trampoline is controlled by mouse. Well, our trampoline moves left and right, and our trampoline is controlled by the mouse. So I'd say that just about does it for the trampoline, wouldn't you? That was pretty easy. Just a few nodes. When the green flag is clicked, the forever node and the set X2 node and the mouse X node. And by strategically placing them in specific points, we've successfully created our first interactable little bit of programming. Well, maybe not for you guys. Do you want the trampoline to have a starting position? That is an excellent question. In many situations, I'd say yes. However, here's the kicker. Because we test for the position as soon as we click the green flag, having the trampoline be in a starting position, I know I keep dragging the trampoline back to sort of the middle of the screen, but that's just my sort of OCPD kicking in a little bit, which I don't actually have. It's just I'm being very particular about it. But see, here's the thing. As soon as I click the green flag, it's going to pop right to my mouse position. So I could stick it in there, but if we reset the position of the trampoline at the beginning of the code, it would happen and then set itself to the position of the mouse so quickly that we might as well not have it. Now we could set it up so that it would wait a certain amount of time until we got the mouse to a position that we wanted it to be in, and then it would start tracking the mouse position. That's certainly something we could do as well. But in this particular case, we're going to have the ball start to move as soon as the game starts. We're going to have the trampoline start to move as soon as the game starts. So we might as well just not have to worry about resetting the position on the trampoline. But I like where your head is going. I like the fact that you thought about that, because in many cases, like for instance, the ball, we will have to reset it to a starting position. So I'm glad you're thinking of that. So pop, I'm going to hit the red stop sign, the octagon. What about our preset Y value? So if our code's functioning correctly, it should never move off of its Y value. So we should be able to move it to the Y value we want while we're editing the scene. Say, for instance, we go like, this looks good, like right here is good. And then it should never, ever, 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 ever move from that Y value because we're not affecting it, right? So it's basically a set and forget. We set it once and we go, okay, we're good. Boom, look at that. Ooh. And we have our little internal freak out. Again, I realize that I'm sort of going against these things that I'm saying because I keep moving the trampoline back. And that's just because I'm particular. If you want to do that, you're more than welcome to. I'm just saying it's not, strictly speaking, a necessary thing and not something I'm going to mess about with right here. What I am going to do is I'm going to move to the ball next, because the ball is going to be where the bulk of our code happens. So first things first is we want the ball to be moving, and we want the ball to bounce off of walls. These are going to be our starting criteria. In fact, if we check our little design document, ball moves forward always, ball bounces on walls and ceiling. By putting in that code, we will be able to tackle those two things. So let's give it a try. Under motion, we've got move 10 steps and turn and stuff like that. So we're going to drop in that move 10 steps. And Scratch is really useful for this one feature. well, it's useful for a lot of things, including learning coding and stuff like that. But it's got this one feature right here that's super useful. It's just if on edge, bounce. And we'll just attach it right to the end of that move 10 steps. Just like that, just like nothing. If on edge, bounce. And what that's going to do, as you probably already guessed, is if the ball hits an edge, it's going to make it bounce. Then, of course, we've got to wrap it in our forever loop, so it does that forever. And we got to stick a when green flag clicked event on top of it so that it starts when the green flag is clicked. And let's go ahead and, hey, look at that. Ball's moving. Ball is moving and bouncing back and forth perfectly straight and not actually heading towards the trampoline at all. Now we have this could theoretically happen in Pong, but this would not be very interesting at all. We're not getting any points for this, nor are we anywhere remotely close to losing. So what do? Well, we need to throw a wrench into this. We need to make this a little bit more interesting, so to speak. So let's test a thing. Let's say we turn the ball clockwise 45 degrees. And we just stick that in before our forever loop. Let's go ahead and run that. Sure enough, now the ball's bouncing. Ball's moving and bouncing off of the walls and the ceiling. However, it's ignoring the trampoline. And it's also bouncing off the bottom, and we're not losing the game. We'll get to that, but let's address the trampoline first. Also, for funsies, yes, I just said funsies. You'll notice that I put this turn 45 degrees outside of the loop. There's a very specific reason for that. Well, let's try putting it inside of the loop and see what happens. Yeah, that's not useful. It's moving-ish, sort of. What if we made it 15 degrees? I'm sure you can see what's happening here. Now the ball is turning each loop as opposed to just moving each loop. And so it's just running in a circle, which is not ideal. I mean, it's good that the ball can do that, but it's not what we want. We want the ball to move straight until it hits an edge. And we enable that by only having it turn 45 degrees at the beginning. Notice that as I do this, the ball heads in a different direction, but it's a predictable one. It's just 45 degrees clockwise compared to how it was before. It doesn't exactly do it perfectly, but it's also bouncing off the edges. So yeah. Anyway, so far so good. Now we need to make sure the ball bounces on the trampoline and that the ball does not bounce on the bottom and the game ends if the ball hits the bottom. So let's hit the ball hitting the trampoline first. I'm going to introduce you guys to the if statement in doing this. I'm sure you guys are already at least somewhat familiar with the if statement, but I'm going to give you guys a formal introduction. So, now you've got a third party that's come along and been like, hey, so here's the if statement, as opposed to you guys just sort of awkwardly interacting with each other at a party and not really knowing one another's names. You're going to find it in the control. If you go to the control, well, we're familiar with the forever loop. But we've also got this if then and if then else, and wait until they repeat until, but we read about that other times. We're interested in the if then. If then is a fantastic little bit of programming. And this is one of the three sort of foundation, tentpole, whatever metaphorical thing you want, bits of programming. You've got loops, if statements, also known as control flow, and variables. We haven't really touched on variables yet, although we've used them. We haven't really touched on variables yet. But now we're going to touch on if statements. So if statements allow your programs to become a whole lot more interesting. Whereas loops allow your programs to run forever with a lot less effort on your part and allow things to, be repeatable and stuff like that. If statements allow some semblance of change in your program. Imagine a program without if statements. It would be like watching a movie or like a show or something like that. You could watch that show over and over again, but it will be unchanging each time it runs. You'll always know that, hey, this is the point where there's the one character who's wrong, and then the bad guy says the thing, and then the main character believes them, and then they all decide that it's a good idea to split up, and one of them decides that it's a good idea to go into the forest or whatever. And no matter how many times you yell at the TV and go, hey, no, don't do that, they'll still do that. There won't be any change based on sort of the status of the movie. They won't sit there and go, well, maybe this time we shouldn't do that. Or, you go, hey, don't do that, and then they don't do that, and then the whole movie is different based on that. If statements allow you to switch things up. So what we're going to do is we're going to attach it to the top of our loop because we always want this to run no matter what. But if statements work a little bit differently. If whatever's inside this little hexagon turns out to be true, then run whatever's in here. If it's not true, then don't run whatever's in here and move on. No matter what, you're always going to run the stuff after it though. So we always want to make sure that the ball moves and bounces on an edge. However, it's not always going to be hitting a trampoline. So we want to make sure that it does something when it hits a trampoline and doesn't do that thing when it's not hitting the trampoline. It's pretty straightforward, right? So let's go over to our sensing category, because a lot of the stuff in our sensing category involves these similarly shaped hexagons. Well, our operators do as well, but sensing is where we're going to find our answer. So we want to say that if the ball is touching the trampoline, then do a thing, which, hey, look at that. The very first result seems pretty promising. If I slot it in there and then click on the drop down, oops, and select trampoline, now we're getting somewhere. So if it's touching the trampoline, then we want it to do something. Let's go back to our motion because we're going to change the motion of the ball. We're going to have it point in a specific direction, in this case, up. If we click on this, we can see right, left, up, and down. We want it pointing up, so we're going to select that. Boom. Now it's going to point up. And then we're going to have it rotate. So it's not just shooting up and down. It's actually going to rotate 15 degrees clockwise. So again, we're going to have it rotate clockwise. And let's hit the green flag. It hits the bottom. Whoop. It hits the bottom. It sort of does whatever it will. But every time it hits the trampoline, it goes to the right just a little bit. And that's how we know that it's hitting that trampoline. Also the fact that it goes in the other direction as soon as it touches the trampoline. And this is the execution of a successful if statement. If we were to move the trampoline out of the way, like right now, boom, it doesn't go to the right anymore. It's not going to the right. Now it's going to the right, but only because, this is the direction that it's bouncing towards. So we can change the direction of that, boop, by letting it hit the trampoline. I think you get the idea. Now, there's a little wrinkle in things. Let's make it a little bit more interesting. If we go down to operators, there's this one operator in particular that I'm interested in. It's the pick random 1 to 10. I'm actually going to drop that in this turn 15 degrees. So now it's turn pick random 1 to 10 degrees. And instead of 1 to 10, I'm going to make it negative 30, whoops, to 30 degrees. So this should be pretty interesting. If I do this, Now the ball will sort of go in a random direction. And this makes the game a lot more interesting because now we don't know if the ball is going to go left or right. We don't know if it's going to go up a little bit or left a little bit or right a lot or whatever. So now there's a small element of challenge. All in all, though, I'd say I'm pretty satisfied with that. So we can knock off ball bounces on trampoline. So we've got ball moves forward always, ball bounces on walls and ceiling, ball bounces on trampoline. There's one more thing we should probably do, and this relates back to Eric's point. We should probably reset the ball back to the center of the screen. Because otherwise, if we get down to the losing condition of the game and it's hanging out there in the bottom when we restart it and it's still in the losing area, well, that's not so great. So we go to motion and we can go to X and Y. And we'll just stick that right above the turn 45 degrees and fill it with 0 and 0. So now it goes to X0, Y0, which should be the center of the canvas. And then it turns 45 degrees from where it was facing before. So now every time we start it, look at that ball go. It's always starting from the middle. And as you can see, it kind of does a nice little spiral thing because it's always turning 45 degrees from where it was turning before, which is fine. Theoretically, you should not be, restarting it this often, so you wouldn't really notice that. And if we really wanted to, we could also stick in another pick random into here to keep things a little bit wackier. Not necessarily a bad direction or idea, for something to do on your own time. But so far, so good, right? It's at a losing condition because, and well, this statement that I'm going to make would be argued by a lot of people who analyze games for a living. This is not a game. What we have right now is we have a toy. And that's all well and good. Toys are cool. Having toys are nice. But this does not constitute a game because we don't have a win condition and we don't have a lose condition. And that's the part that could be argued by a lot of people. It does not have a win condition and it does not have a lose condition. It does not have a means of, keeping track of anything. So let's start by adding a lose condition because I am a pessimist. Hooray! Yes. Also, excuse me for a moment. I'm going to cough my lungs out. Excuse me for that. My throat was very dry. I know you didn't hear any of that, but I'm going to excuse myself anyway because it got awkwardly quiet. Anyway, so let's go ahead and add a lose condition. What we need to do is we need to make sure that anytime the ball hits the bottom here, gets past the trampoline, whatever, you lose. Because you don't want to do that. So we need to figure out how exactly we're going to make that work. So let's check out our options here. We can use a control and stick it in if statements. And what are we sensing for? If it's touching the mouse pointer, no. If it's touching a color, the distance to the mouse pointer. If the X position of the trampoline is a certain value, if the reset timer is a certain value, if the username is a certain value, if the loudness is a certain value, none of these really seem to be speaking out to me, except for maybe one is promising. I'm thinking that there's one in this whole thing that could be a potential answer. And it's touching color. Now bear with me. Here's what I'm thinking. What we do is we make a rectangle all along the bottom that is a certain color, a very bright color that cannot be mistaken for anything else. And if the ball is touching that color, then the game ends. I think that sounds pretty good. So let's go ahead and let's drag that one over here. Perfect. And I'm going to do a little bit of cleanup as well. What I'm going to do is I'm going to take this and sort of move it over into its own thing. And throw both of these into their own forever loop that starts whenever the green flag is clicked. And you might be going, well, that's weird. Why would you do that? That's because Scratch always moves from top to bottom when it's running its code, right? That's something that I mentioned on Tuesday. For something like this, though, that also means that if this game-ending if statement was underneath this move 10 steps and if on edge bounce, the ball would still move a little bit before the game ended. Now, you could solve that by moving it above it, but it's also kind of nice to not have everything run serially and kind of run at the same time. I'll let you in on a dirty secret too. It's still not all running at the same time, but that has to do with how Scratch handles things on the back end. But let's pretend that everything's going to be running at the same time. These two things are going to be running at the same time. So we're going to do that so that we know, so that this is checked separately from this. So we'll move this over here. So forever loop, if touching trampoline, then point in direction 0, and then turn into a random direction, and then still move 10 steps and bounce if on edge. And if touching color, then let's just stop everything for now. Just stop all. So if it's touching that really bright blue color, then stop all. So let's go ahead and create our little losers area, I guess, for lack of a better term. I don't know why that was the first thing that popped in my head. So that this ball has some place to go and have you lose. Words are starting to fail me. All right, so what we're going to do is we're going to use a new sprite. Best thing to do is just one solid color, which we can do by clicking on this little paintbrush here, which is to paint a new sprite. And I'm going to select this nice angry red because, I mean, that seems appropriate, right? And then I'm going to select the rectangle and then just draw a rectangle from one side to the other. I want to make it, like, just fill it up horizontally so that that rectangle takes up the whole sort of drawable area. That's perfect, except for the fact that the rectangle is empty. It's doable, but not exactly perfect right now for our purposes. I'm actually going to fill it with a color. I'm going to select this little paint bucket over here and just click in the middle, and boom. Now I got a big solid red rectangle that looks really mean, and that's exactly what we want. That's perfect. So I'm going to go ahead and click back over to scripts along the top here because we were just in the costumes area. And I'm going to drag this red rectangle down here. And it's going to hang out at the bottom. Whoop. Come on. It's going to hang out at the bottom. And I'm going to try and make sure that it takes up the whole bottom because, you know, you want to make sure that the whole area is a danger area for the ball. Now we've got one final thing we've got to do. If we select the ball, we see if touching color blue. That is very clearly blue. We want to make sure that it's this red. So what I can do is I can click the little square, boop, and my cursor turns into a pointer finger. And if I move this pointer finger over stuff, you can see that the square populates itself with a different color. It's actually searching for the, like, we're searching for the color, but it's letting us know whatever color the cursor's over. So if I mouse over the red rectangle so that the square turns red, and I click so that it becomes a regular pointer again, as you can see, the red color sticks. So let me hit the green flag. Everything bounces like it should, sounds good, looks good. Doesn't really sound good because it's not really making any noise, but it looks good. If I move the trampoline out of the way, oh, hey, look at that. I'm no longer controlling the game. It automatically stopped. And with that in mind, we've automatically created a losing condition. Bam, just like that. So ball does not bounce on bottom. Game ends if ball hits bottom. We're getting there. We have one more thing. Ball bouncing on trampoline gives player points. However, that is going to touch on variables. And I want to devote at least 15 to 20 minutes on variables because that's the kind of person I am. I talk a lot. So you're going to have to hear me talk about that next time. For now, though, what I'm going to do is I'm going to do the poll questions, and then once that's done, I'll leave it open for question and answer time until about 2 till, because then I have to get prepared for my next class. So we'll try and get through the poll questions as quickly as possible so that you guys have as much time as possible to ask questions about anything you might have. If you don't have any questions, you are more than welcome to head out after we're done with the poll questions, and then have a wonderful weekend, and we will see you on Tuesday. So here we go.